The next type of relation plots is heat maps. It's a graphical representation of data where values are depicted with colors. It is useful for visualizing matrices and tables of data. So some of the example we had already seen while discussing with correlation matrices and on. So here the color represents the magnitude of the values, and the key features here are color mapping, metric representation, annotations and labels for each row and column. So where these types of maps are used, so it is visualizing distribution of values across categories or time intervals. So if we are trying to visualize the distribution, then the heat maps will be useful. It is very much useful when you are trying to identify the patterns or trends or anomalies within the data set. Useful for comparing the magnitude of values between different categories and groups, because these colors talk about the magnitudes, and heat maps are widely used in fields such as biology, finance and data analysis for visualizing large data sets and to identify relationships between the variables. So this we had seen in the previous session, that in one plot so much of information was hidden. So when it comes to large data set, and if you are trying to visualize them, then heat maps are the best way of doing it. So to ensure best results out of working with heat maps, let us see some best practices. So make sure to choose a color palette that effectively communicates the range of values in the data set. It is essential to select colors that are distinguishable and accessible to the viewer. So make sure that the colors are distinct and can immediately differentiate between the neighboring colors, so that it is easily recognizable, accessible to the viewers, and they could understand the overall message what we are trying to convey to them. So always better normalize the data to ensure that the color mapping accurately represents the relative magnitudes across the rows and columns, not the absolute magnitudes. So don't just try to put absolute magnitude here. Make sure to use the relative magnitudes and work with them. Always we must include appropriate labels and rows for rows and columns to provide the context. So in the last session we had seen, so we could able to talk about what features they are trying to connect and all that, because label was given properly. So instead of representing each row with a label, because the same label was used for row and column, because they were trying to correlate with the same data, same features. So each row, each column, the diagonal one is trying to correlate with the same feature itself. That doesn't make any sense to us, because the first row, first column, they talk about relation between itself, the first feature itself. So first feature will always match with the first feature. There's nothing to talk about. So instead of saying 100% matched, you can just leave that and write the name of the feature there. That's what we had done in the previous session. And make sure that all these labels are properly put, and we need to make sure that annotations within each cell to display the precise numerical values, especially if the heat map is used for quantitative analysis. So if the quantitative data is there in each cell, then along with the color, also make sure to write the value inside the cell so that we can easily make out what value it is talking about. Overall, the colors will tell how the things are and the overall trend and all that. But in if you want to minor details, so you can get into each cell and see carefully what values are listed there. So we can experiment with different color scales, including sequential, diverging, categorical color schemes to find the most suitable visualization for the given data. So before concluding, just try all possible color scales and see, and whichever gives the best visual effect, use them. So here we have one example of the heat map. Here what we are seeing is the rows represent one category and the columns represent one category, and if you look carefully, then rows talk about one value. No, rows and columns have same meaning. So we can see that all the major diagonal is written with 1 1 1 1 1 1, which means that that's the first row, first column are same, so it is 100% correlated. So this way of representation is not very well suited, as we have seen in our previous session. A similar type of heat map was used, but because the rows and columns are talking of same features, then instead of writing rows, columns, the titles, the labels separately, we could have written them in the place of 1 1 1 1 on the major diagonal, as we did in the previous example. Anyway, here on the right side we have color palette, shows that minimum has got a dark value, maximum has got a green value. A light green is maximum. On the way go down, the green becomes darker, 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 and finally it becomes totally black. Now, if you look at the heat map, then we can see some places, some cells are darker, some cells are lighter, some are very good green, light green, some are dark green, some are of various different shades, some are black, some are. So if you look at that, we can see that how each of the parameters are correlated. So details, many details are available, and this is talking about some annotations are also given, that each cell is given with a number, so you can look into each cell and find out how much is the value there. And on the uh, heat map, you can also see the color palette and the number for each color is shown there, and we can make use of these colors to represent here. So this all, what is it? If you look at it, 3 plus 3, 9, 6, 9. So there are totally 12 features being used here, and a 12 by 12 matrix. So there are totally 144 values. So you are talking about a matrix with 144 values, the 12 by 12 matrix, and if you just put that in the form of numbers, then nothing is visible, nothing you can make out of that. But instead of those numbers, if you fill the cells with appropriate colors as per the color palette you used, then we can make out more information out of it. So like the first row and third column, there is some uh, greenish is there. It's more towards the maximum, but not very much maximum. So it says that between first parameter and third parameter, there is a better positive correlation, and with the first parameter and second parameter, it is almost dark. So we can say that it is having a negative correlation also, because depends on the sign. Yes, the black one is talking about minus zero point 0.6, and the light green is talking about 1. So depending on the color shade, look onto the palette and then identify how much it is, or just look into the cell. Some numbers are written accordingly, you can make out, but those numbers don't directly match with the numbers we have here. Sometimes they match, sometimes they may not match, depending on the normalization, whatever. So it's difficult to just understand what this whole map is talking about if you consider only numbers. But instead of numbers, if you fill the cells with appropriate color from the color palette, then we can make out things very easily. So that's the main purpose of the heat map, that you can represent maximum. At one glance you can understand the overall picture of the whole data you are talking about. So that's about heat map, and that's about the relation plots. So the next session we begin looking at the various types of composition plots. So till then, keep watching. Thank you.